Yes, members, can we look at question 2? But I believe what I've sent people have understood, right? I remember sharing with you some of the work. Baptist.
Yes.
I remember sharing this question with you.
I'm in a noisy place. I will not.
Okay, Stephen. Yes, Stephen.
Yes, teacher. Yes, teacher.
Have you finished that? I remember guiding you on that question. Teacher. I remember guiding you on question 2. Have you finished doing it? Okay, let's look at it together. They're saying a particle X traveled with a constant velocity of 6 meters per second.
Yes, teacher.
Along a straight line. It passes a particle Y, which is stationary. 1 second later, particle Y accelerates at this one. There should be correction there, members. This one should be meters per second squared. How long after being passed does it take for Y to draw the same level with X? Now that can you leave your answer inside form? When you see such question, members, which means at this point they're telling you the equation, you must form a quadratic equation. That one is a must. If you cannot form a quadratic equation, which means they are going to have a problem because there's no way you're going to express those questions or those expressions inside form. But how are you going to form the quadratic equation? You must understand what is given there. So let's look at particle. We have 2 particles there. We have particle X. Particle X they're saying is moving with a constant velocity. Constant velocity. V, which was given to be 6 meters per second. We said when a body is moving with a constant velocity, which means velocity is not changing. And when velocity is not changing, which means the body is not accelerating. Accelerating. Because velocity is constant. Constant. Are you together with me, Stephen?
Yes, teacher.
Yes. Which means acceleration is going to be 0. Since the particle is moving with a constant velocity, it implies that acceleration is 0. So our acceleration will be 0 meters per second squared. That's for particle X, because velocity is constant. It's moving along a straight line. Remember here, what we are still looking at, all the motion we are going to deal with, because we are looking at linear motion, which means it must be in a straight line. So we don't know the time. That one we don't know time. Time was not given for particle X. So we can call it, let's call it Tx. We can call it Tx. That's time for particle X. Then we also have another particle. We have particle Y. Particle Y, which was stationary, which means the initial velocity, our U will be equals to 0 meters per second, because it was at rest. It is at rest. Then 1 second later, it accelerated at a rate of 2 meters per second squared. So acceleration was given to be 2 meters per second squared. Now, what does it mean? 1 second later. It means for this particle X, for particle Y to be at the same level with the particle X, particle Y must move faster. Particle Y must move faster than the time of particle X. By what? Less by 1 second. Should be less by 1 second. Because I said 1 second later. So which means ty will be, should be tx minus what? Minus what? Minus 1 second. So that they can be at the same level. So that they can be at the same level. Stephen, are you getting me? So that's the condition for bodies to be or to move with the same velocity or to be at the same level. Then they're saying, how long after being, which means they're asking for time. They're asking for time. After how long, after being passed, does it take y to draw level with the particle x? Which means for x to be at the same level, for particle y, to be at the same level, with particle x, they must be at the same point. They must be at the same point. Which means the distance they must be having the same distance, which means distance x must be equals to distance what? Y. Distance x must be equals to distance what? Y. Are you together, Stephen? So using s equals to ut plus a half at squared. So that's the formula we have there. So for x will be, remember acceleration is 0, which means we shall have, velocity was given, so 6 times the time which we don't know, which is tx, plus a half times acceleration, which is 0, times tx squared, equals to this one now, sy. So sy, if we substitute, our initial velocity is 0, so we shall have 0 times ty plus a half times acceleration, which was given to be 2, time which is times ty squared. So we find that this one now we shall remain with only, this one is going to give us 0, here is 0, so we remain with only 6 t what? Tx equals to, this one is 0, then we find this 2 will cancel with the other 2, then we remain with ty squared. But what is ty squared? Ty, we have got it here. So it's going to be, so it implies now 6 tx equals to, into our tx, our ty, which is tx minus 1 squared. If they would have said 2 seconds later, which means here we are going to subtract 2, which means it must be less by 2 seconds. But since here they have said 1 second later, which means time taken for particle y must be less by 1 second. So when you expand this, members, what do you get? So we get 6 tx equals to, what do we get here? We get tx squared minus 2 tx plus what? Plus 1. So you can see now our quadratic equation is coming there. So remember, it must be in the form of ax squared plus bx plus c equals to what? Equals to 0. So can we rearrange our equation? So when we rearrange our equation, we shall have tx squared minus 2tx plus 1 equals to that.
6.
Collect the light terms. So collect the light terms. So we shall have tx squared minus 2tx minus this one
Minus 8, 6.
Minus 6. So
Plus
plus
1.
1 equals to 0.
0.
So this one will give us tx squared minus 8 tx plus 1 equals to what? Equals to 0. So now you can see is now in the form of ax squared plus bx plus c equals to what? 0. You don't need to go for complicated method here, members. Just go for a simple method, which is quadratic formula. So you said using quadratic formula, which is given by x equals to negative b
plus or minus
b squared
b squared a plus
over what?
2a.
Over
2a.
2a. So from our equation, from our equation there, what is our a? What is our a? Our a is what?
1.
1. What is our b? Our b
Negative
is
8.
and our c is what? Our
1.
C is 1. So substitute. So when you substitute, you now since our equation is in terms of t, so which means this here we are just writing the formula. So make sure you be consistent. So now we shall have t what?
Negative
Tx. Tx, because our equation, our quadratic equation was in terms of tx. Equals to our negative times negative will give us a positive there.
8.
Right? Plus or minus the square root of 64, not so?
1. Negative 8 square. Yeah.
Which is
68.
Which is 64.
64.
4 times?
Yeah.
4 times 1 times what?
4 times 1
times 1.
times 1.
Over what? Over 2 times 1.
Over 2, 1
Times
1.
So we'll have 8 plus or minus the square root of 64 minus what?
Minus 4.
Over what?
Over 2.
So Tx is equals to 8 plus or minus the square root of what?
The square root of 60.
60 divided by 2.
2.
Now here you must remember simplification of sides. Recall.
Yeah.
Recall what? Simplification
of sides.
of sides. Simplification of sides. How do you simplify sides? You said you think of two numbers where one of the numbers must have a what? A square root. So you see that root of 60 is the same as the square root of 4 times what?
Times 5 times 15.
Times 15. So you find that we shall have root of 4 times root of what?
Root of 15.
Root of 15. We know the square root of 4, not so? Which means it will give us 2.
Yeah.
It will give us 2
root of 15.
2 root of 15. I think that.
Yes.
Yeah, we cannot simplify 15 further because 15 is a rational. Square root of 15 is a rational, so we cannot simplify it further. So we come and put it back here. So it implies now our Tx equals to 8 plus or minus root of 60. Root of 60 now, which we got what? Is 2 root of what? Root of 15.
Root of 15.
Over what? Over 2.
Over 2.
So what you do here, you distribute the LCM. You distribute the what? The LCM. So we shall have Tx. Tx will be 8 over 2 plus or minus, okay? 2.
Yes.
The square root of 15 divided by what? Divided by 2.
Divided by 2.
So Tx will be equals to 4 plus or minus. This 2 will go away with this 2, not so? Then we remain with what? Root of
15.
Root of 15. I think that.
Yes.
Now, to get the answer, the exact answer that they wanted, remember we said Tx, Ty,
yes.
Ty must be less than Tx by 1. So let's prove this answer here. Let's check our answer. Which one is going to be the best time we can take? So if we find that all of them are more than 1, if they are more than 1, then we shall take all of them. Are you together?
Yes.
Yes, because Ty must be less than Tx by 1. Okay?
Yeah.
So let's work it out. I'm just going to, you can prove it with your calculator. So we have 4, okay? 4 plus root of 15. I think that. What do you get?
Yes.
We get 7, not so?
7 points.
That one is a positive. Yeah. So our answer is either Tx is equals to 4 plus root of 15.
Root of 15.
They told us to leave our answer in the sides, okay?
Yes.
Or tx is equals to, what about when it's negative? So we shall have 4 minus root of 15. We get 0 point. I think that.
No. Yes.
4 minus root of what? 15. Remember, for y to catch up, it must move. The time for y must be less than what? The time of what? X by what? By 1.
By 1.
Now, when you see, when it's minus, which means we get the time is what? The time is 0. I think that.
Yes.
So which means which time are we going to take? Are we going to take the plus or the minus?
The plus.
We take the plus. Good. So therefore, tx is equals to 4 plus root of what? Root of 15. Root of 15. Remember, we are not looking for tx. We are not looking for the time of x, because when you look at the question, it said how long after being passed does y need take to draw with the same level with the x. Remember we said, recall. So remember we said ty, do you remember that? Ty is equals to tx minus what? Minus 1. Do you remember that?
1. Yes.
So which means, so ty will be equals to our tx, which is 4 plus root of 15. Then take away what? Take away 1. Remember, subtraction operation of SAD. We said a SAD can either be added or subtracted unless if they are of the same order. Unless if they are of the same what? The same order. So which means we have ty equals to 4 minus what? Minus 1 plus root of what? Root of 15. Are you seeing that?
Yes.
So therefore, our ty is going to be equals to what? 3 plus root of what?
Root of 3. Root of 15.
Root of 15. Have you seen that? Is that what we have here?
Yes.
Have you seen it? That's what we have there.
Yeah.
Have you seen that?
Yes.
I think we are together on that.
Yeah.
Good. Now, another question which is related to that is the question number 3. I think this question number 3 here. I think this question here.
I'm seeing it.
Yes.
Yes, sir. Yes, sir.
So it's the same question. It's the same. Okay?
Yes.
You do it the same way. So in case they were asking for distance, here they were asking for time. In this question, in this particular question, they were asking for what? They were asking for time.
That's for the time.
What if they were asking for distance? What were you going to do? Now we come back here. We come back here. So if in case they were asking for distance, in case they were asking for what? Distance.
Yes.
Remember we said xx we got what? Was what? 6 tx. Do you remember that?
Yes.
And sy was what? What was sy? What was our sy?
Tx.
What?
Tx minus 1. Tx minus 1 into brackets squared.
Look at let's check. Let's check.
Tx, yeah, it's down.
Yeah.
Oh no, it's down. Yeah. It's tx minus 1 into brackets, all of them squared.
It was tx minus 1, but what?
Minus 1 into brackets squared.
Okay. So yes. Now we have got time. So we said which time are we taking? We are taking tx equals to what?
Yeah.
4 plus root of
15.
Root of 15 seconds. Not so?
Yes.
So now, which means Sx, what will be our Sx? Sx will be, we shall have 6 times the time, which is what? 4 plus
root of 15.
Root of 15.
Into brackets.
So Sx will be, this will give us 24 plus 6 root of what?
Root of 15.
What? Meters. Have you seen that?
Yes.
Then Sy Sy will be tx minus 1 squared. Okay?
Yes.
So we found out our Sy will be equals to, we got that time is what? We got that time was 3 plus root of 15 squared. Do you remember that?
15.
Do you remember?
Yes.
Uh-huh.
Yes.
Good. So when you expand this, what do you get? When you expand this, it's the same as 3 plus root of 15 into 3 plus root
3
of
plus root of 15. 15.
You should know how to
Yes.
expand that. This and this will give us 9. Not
9.
so? Plus
Yes.
3 root of 15. Not so?
15 plus 3. 3 root of 15
plus
15. 15. It's 15. It's 15 direct, not square. Yeah. It's not squared.
First give me under the square root. What is under the square root? Is what? 220? 225. Because I've already written, I don't want to spoil my work, okay?
Yes.
So Sy will be 9 plus, this will give us 6 root of 15.
Root of 15
plus 15.
15.
So Sy will be 15 plus that will give us 20.
24.
24. Plus
24.
6.
6 root of 15.
Are they not the same? Are they not the same?
Yeah, they are the same.
That's why we say they must be at the same what? At the same what? At the same level. Have you seen how you prove your answer?
Yeah.
Yes. Very good. Very good. So, I think we are together on that.
Yes.
Very good. Very good. So the rest people were able to do them. So this one, these graphs, I'm not, should I waste time explaining these graph members?
No.
These graphs, you can copy them, right?
We know.
Yes, those graphs we know them.
Copy.
Now, subheading, motion under gravity. Subheading, motion under gravity. Motion under gravity. Motion under gravity.
Mathematics. That's why you're not here. I need some.
Motion under what? Motion under gravity. You have learned this one in O level. Who can just talk about it briefly? Stephen. 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 When we talk of motion under gravity, what do you remember? What do you still recollect from what you have learned from O-level physics? What do you remember? When we said motion under gravity, what's coming to your mind? Yes, Stephen or Baptist?
Yes.
When we talk of motion under gravity, what's coming to your mind? What comes into your mind?
It's like a body is now falling towards the center of the earth.
It's falling, not so?
Yeah.
Which means the body is now no longer, there's no force that is going to be exerted on it. The only force that's is going to be due to its weight. It's going to be due to its what? Weight. Which means the body is either falling or is being released in space. Or is being released from what?
Yes.
From space.
In space.
Yes. So which means now, this time our acceleration is going to, our acceleration now will change to acceleration. Remember, we use A when is it? Horizontal what? Horizontal what? Horizontal motion.
Horizontal motion.
Which is it? Motion in that. This is when it's still under the straight line because linear motion is divided into two. Okay? Linear motion.
Yes.
Is divided into how many? Into two. We have horizontal.
Into.
Horizontal motion. The first one which we have looked is an horizontal motion, okay? Where acceleration.
Yes.
Where we use acceleration A. Then the second one is the vertical.
Vertical motion.
Where acceleration now become what? Acceleration due to
G.
Which is
gravity.
Yes. And acceleration due to gravity is a constant. Acceleration due to gravity is a constant.
A constant.
As long as you are on Earth, on the planet Earth, the acceleration due to gravity remains the same. Okay?
Same.
Yes.
Yes.
And that value is what? Our acceleration due to gravity is 9.81 meters per second squared.
Per second squared.
Yes, that's what we use in physics. Okay? And this value is already in your calculator. Do you have your calculator there with you? I want to show you how to put this thing in your calculator. In O level, you are using what? You are using 10, not so. In O level. But in A level, we don't use 10 because the most accurate value is 9.81. So when you want to find that value, we can find it from our calculator. Do you have this cover? Are you seeing this cover here?
Yes, we are seeing.
Do you have yours?
No.
Yes. Now you come to, I think this one, scientific constant. Are you seeing scientific constants?
Somehow, I cannot see very well.
I'm trying to zoom. I'm trying to zoom. Are you seeing it now?
Yeah, we can see. I can see.
Good.
I see it.
I've zoomed in a bit. So these are scientific constants. Are you seeing them there? Constants. There are 1 up to 40. All these constants you know in physics, they are found in our calculator. They are already in our calculator. So acceleration due to gravity is number 35 in this table. Are you seeing it there? Number 35. Have you seen it? Members, are you seeing it? Acceleration due to gravity is number 35. So if you want to press it, if you want to press that, you press constant. You press constant. Are you seeing constant here? Are you seeing constant here? So you press constant, and then you press that number, which is 35, constant 35. Are you seeing what is displaying on the screen? Constant 35. Then if you want to get the value, press equal sign. You see that you get 9.80665. But for the purpose, we round it up to 2 decimal places. Members, have you seen that? Stephen, have you seen that? Stephen, have you seen that? Stephen, you are talking, but I can't hear you. Yes? You have seen that, right? All right. All right. So I wanted just to show you that so that we don't waste a lot of time pressing those values. Those values are already in our calculator. So let's start with the vertical motion. Vertical motion. That is under vertical motion, then subheading vertical motion. Vertical motion. Vertical motion. So we said when a body is projected vertically upwards, when a body is projected vertically upwards, its acceleration A, this time because it's moving upward, which means it will be against gravity. The body is moving against gravity, which means the acceleration will be negative. The acceleration due to gravity will be negative. So our acceleration A will be equals to negative what? Negative G. Negative G, so which is equals to, so G will be equals to negative 9.81 meters per second squared. This is when the body is moving what? This is when the body is moving upward. Okay? Stephen, are you with me? Stephen? Okay.
I'm with you.
Okay, that means that acceleration due to gravity will be negative. So this means that the velocity, when we talk of acceleration, acceleration means the speed of a body, of a moving body is changing. In 1 second is, take for example, if it's 9.81 meters per second squared, it means in 1 second, the speed is changing by 9.81 meters per second. That's what it means. That's what acceleration means. Okay?
Per second. That's what
okay?
it means. That's what
so
okay?
it means that the velocity of a body decreases by 9.81 meters per second after every second. After every second. Till the time when the velocity is 0. And this velocity, for velocity to be 0, that takes place at the maximum height. That's why when you throw a body up, take for example, a ball, like a stone, you can put any body. When you throw it up, you find that it will move. When it's moving up, the speed is reducing or decreasing by 9.81 meters per second in every second. So it will move like that until the speed reduces to 0. And the speed will reduce to 0 when that body is at maximum height. Are you together? At maximum what? That's why when it reaches the maximum height, at that point, the velocity will be 0. That's why it's not, the body will start falling back. Now it will start, its weight will now start acting on it, then it will bring it what? Down. And at that point, when it's coming down, now that one now, when the body is now falling, is part B. Is part B. We said an object falling freely vertically downwards has an acceleration which is now positive. At that instant, when the body is now coming down after reaching the maximum height, or you have dropped a body from up, could be from the top of a building, could be from a steep point, any point up above the ground level. So at that point, the acceleration will be a positive value. So falling, or moving downwards, falling or moving downwards. At that point, acceleration will be a positive D. So what does that one mean? It means when a body is falling down, its speed is increasing at this point. That's why when a body is falling down, you see as if it's moving at a very high speed. As if, it's an illusion. You can see as if a body is moving at a very high speed. But the speed is remained constant. The speed remains constant because the speed will still be 9.81 meters per second in every second. So it means it will be decelerating or accelerating it will be accelerating, sorry, at a rate of 9.81 meters per second in every second. Have you got that one?
Yes.
Steve, have you got that one?
Yes.
Very good. Take note of that. Take note of that. So we are saying an object freely falling vertically downwards as an acceleration of that is that. This implies that its velocity increases by 9.81 meters per second after every second. That one I've already talked about it. Now definition. Let's define acceleration due to gravity. Definition. Write down definition. Definition. So acceleration due to gravity, remember, is still acceleration. But this time, the only difference that the body is now moving vertically. The body is moving vertically. The other one was horizontally. When it's moving, when it's under horizontal motion, we said is the rate of change of velocity. But now what if it's now falling freely? That acceleration now will be called acceleration due to gravity. And we define it as is the rate of change of velocity for an object falling freely under gravity. Don't put this again with time. I said when you put with time, you are repeating yourself. Because with time, red means time in physics. Red means time. So we said is the rate of change, acceleration due to gravity, acceleration due to gravity is the rate of change, of velocity, for, you can say for a freely falling what? Body. A freely falling body under gravity. Under what? Under gravity. As simple as what?
Gravity.
Yes. As simple as that. I don't love the second definition. This one is just That just created it from the definition of acceleration. Remember, here we are defining. We don't. These are, in case if they ask what is acceleration due to gravity, then you can write for me this. You can say is the force of attraction due to gravity exerted on a 1 kilogram mass. That one is derived from the definition. I mean, that one is derived from the formula. So which means at that point, the force that is acting on a body, that force is due to the weight of that body. So that's we remember we said force is equals to M what? MA. This is when the body is moving horizontally. But now when a body is falling, which means the force exerted on it is going to be due to its weight. So that's now this formula now will change to weight equals to M what? M what? Mg. Have you seen that? So now, which means if I make G the subject from here, which means it be W over what? Over M. So that's why they are saying is a force of attraction, is a force of attraction due to gravity exerted on a 1 kilogram mass. Because remember, I told you force is in Newton, which is the same as kilogram, which is the same as kilogram meters per second. Then mass, which is kilogram. You find that this and this will disappear with that. Sorry. So you find that. So you remain with G is equals to meters per second. That's how we derive those units. Have you seen that? Stephen, have you seen that? Stephen, can you talk to me, please? So the definition, the correct definition of acceleration due to gravity is the rate of change of velocity for a freely falling body under gravity. But in case if they ask for what is acceleration due to gravity, then you can say is the force of attraction due to gravity exerted on a 1 kilogram mass. That one can be marked. But the definition is, I told you the definition is either correct or wrong. There's no either in the definition. There's no gambling around definition. But if the question is what is, I said when the question is saying what is, you define and then you give relevant comments. Are you together? Are we together? Okay. Okay, we have just second. We have just less than 1 minute. Less than 1 minute. Then we take a break. So when we take a break, we shall come back and then we continue from there. Okay?
Yes, teacher.
Let me hope the first session was clear for you.
Yes, it was clear.
Very good, very good, very good.